I'm Katrina Allen, Head of Alumni Relations and Regular Giving here at the university, and I'm really pleased to welcome you all to our special event for geoscience graduates. Before I hand over to our academic colleagues from the school, I first need to cover a little bit of housekeeping for people unfamiliar with using this platform. Firstly, you may have noticed pop-up notifications on your screen when people join, leave, etc. And unfortunately, we can't turn that off for everyone, but you can turn it off yourself. And my colleague Gary has put up a slide with some instructions on how to do that. If you haven't done so yet, if you click on the purple icon at the bottom right-hand corner of the screen, this will open the Collaborate panel. Then just follow the steps on the screen to change your notifications. Also, as you'll have noticed, the option to use the camera and microphone have been switched off for attendees, but you can use the chat box at the side to ask us any questions. The chat function is also found in the Collaborate panel by clicking on the purple icon. We very much encourage your questions, and you can submit them at any time you like. Just type them in the chat box and Gary will read them out during the Q&A portion. We only ask that you keep them clear and concise. Also, the little hand icon that you'll see at the bottom of your screen will raise your hand. If you need any assistance, please click this button and we'll reach out to you via a private chat message. And finally, just to note that the session will be recorded and shared online. Okay, that's quite enough from me. So without further ado, I'm delighted to hand over to Head of the School of Geosciences, Dr. David Muirhead.
Hi there, folks. Let me just reiterate again the warm welcome there. Thank you very much for joining us this evening. As has been said, I'm Dr. David Muirhead. I'm the Head of School for Geosciences here at the University of Aberdeen. It's my great pleasure to welcome you here and share some of our new and exciting teaching and research. Now, I'm a geologist by training, but hopefully you'll see this evening that as a school, we're home to some truly interdisciplinary research and teaching, something that we are really extremely proud of. Now, just a bit of a background about where we are just now as a school. We're now home to 4 discipline areas, and this might be quite different from when you were here. We have archaeology, we have geography and environment, geology and geophysics, and our new planetary sciences discipline that just joined us over this last year or so. But please do not be fooled into thinking that these are discrete units that don't speak to each other. Far from it. In fact, over the past few years, the school's been leading the way, I would say, with respect to interdisciplinary research and teaching. And indeed, we have staff actively engaged in these areas across all of the main interdisciplinary challenges from the university's recent 2040 strategy, an image of what you can see on the right-hand side there. For example, we work very closely with the Centre for Energy Transition as we move away from traditional oil and gas related research into other avenues. We have Archaeology and Cultural Heritage MSc just in the last year or so. We have our joint Quadrat PhD programme with our school, the School of Biological Sciences, but also Queen's University Belfast. We engage in machine learning and artificial intelligence for virtual fieldwork and geophysics. And we also use geological or material science techniques even for the detection of cancer. So hopefully what you'll see this evening is us sharing some snippets of recent works from our 4 disciplines, but hopefully you'll see just how vast and far-reaching this work is. In a few moments, you'll hear from 4 of my colleagues who'll talk through some specific recent projects in the school. You'll hear from each of these 4 in turn. You hear a little bit from Linus Lanflink about some bioarthological science and some other regions where archaeology are leading the way. We'll hear about ice stupas and some other aspects of glaciology with Matteo Spagnolo. We'll then head over to our new planetary sciences team, headed up by Javier Martin-Torres, who'll talk a little bit about the work that he's doing. And then we'll also hear a little bit from our new region of virtual geoscience that Jess Pugsley is going to talk to you about in a little while. So we're going to kick off with Linus. He's one of our newest recruits into archaeology. And he's going to talk to you just now and share some of the work in archaeology to date. I'll hand over to Linus just now.
Thank you, Dave. Just waiting for the slides to load. There we go. Thank you. My name is Linus Girdland. I'm a lecturer in biomolecular archaeology. And this is a photo of me. Let's see if I can actually use a pointer here. Can you see my hand here? If I, as a pointer on the slide. Okay. Anyway, my research is truly interdisciplinary and multidisciplinary. When I'm not stuck in a lab extracting and sequencing ancient DNA, I'm out in the field participating in more regular and traditional archaeological excavations. The photo in the middle there is me excavating Lancel Meadows, which is a fairly unique and important archaeological site in North America, in Newfoundland. It's in fact the only confirmed Viking site, and I'm very happy to be part of that research. It's a new research project in furthering excavations at that site. But of course, the department is quite wide. We gather a range of expertise ranging from osteology and the study of human and animal bones, traditional large-scale excavation and fieldwork, ancient DNA and stable isotope analyses, indigenous archaeology, historical and contemporary archaeology, and palynology. And I'm sure I forgot some type of specialty here. In fact, I think Viking archaeology is something we really proud ourselves on too. In fact, we recently became the first archaeology department in Scotland to offer an undergraduate degree that is professionally accredited, which is, of course, fantastic news for us. And we offer a range of either single or dual honors degrees at undergraduate level. The wide range of expertise that we've gathered now in our department is well reflected also in our MSc catalogue. Taught MSc programs, and we have now a growing PGT presence in our department in terms of the number of students, which really drives our effort for internationalization and actually research. We tend to engage our students very actively in ongoing research projects. And well, honestly, I think the quality of our students is really excellent. So I'm really quite happy to be part of this effort. Apart from the taught component, of course, we have research, but we offer good opportunities for students to engage with staff and the research community outside of the classroom and outside of dissertation work and things like that, either via the Archaeology Society or via our weekly research seminars that tend to draw an international crowd, where we invite international speakers as well as national speakers. We have really good attendance, and we also have attendance from staff from other departments. Archaeology, or the research in archaeology in our department, really focuses on two main themes. And for our archaeology projects in general, our flagship theme is the archaeology of the North. And we have many projects based around the unique archaeology of the global North, kind of circumpolar approach here. And we have long-term projects based in Scotland and overseas. For example, we have award-winning projects based in Scotland, such as those driven by Gordon Noble and the Northern Picts projects, and those further afield, such as our community-based projects in Alaska. And specifically, the Alaskan site is really interesting in that it's it's interesting. It's quite sad, in fact, actually, that it's currently being destroyed. It's being eroded into the sea. So very much affected by the current climate change. So we're essentially doing rescue excavation within a kind of community archaeology-based setting. And we are the only centre in Scotland, and one of the only ones in the UK that gathers ancient DNA, isotope speciality, or isotope expertise rather, osteoarchaeology and zooarchaeology in one house, or in one department. And we're really quite happy with that, how it's developing. The bioarthological sciences is really something quite new. In the past couple of years, we've established archaeosteology, we've established ancient DNA and isotopes, and of course, this is reflected in the taught components of our, specifically on the master's level. We also have a relatively unique and really interesting, in my opinion, approach to teaching. So most of our teaching is research-led or research-driven. So we tend to integrate our lectures and seminars with our ongoing research, and also then the theme of archaeology of the North. And we have some award-winning public engagement type projects, such as the reconstructions of a Pictish hill fort at Berg Head that you can see up to your left, and a digital museum that was recently awarded a prize it's based in North America, in fact, but this is the Nunalek site that I just mentioned. And we have on-campus excavations and engagement with historical archaeology and historical context in Aberdeen and further afield in Scotland. Okay, so that's our teaching and research, archaeology of the North, and we've made some pretty good impact in the past couple of years. Gordon Noble's Northern Picts project was featured in BBC just a couple of weeks ago. He was also awarded the very prestigious Current Archaeology Award for Product of the Year in 2020, not 2021 as it's shown here, but last year. And we're currently expanding our research on Scottish Picts, right, or Northern Picts, in part via ancient DNA sequencing and genome analyses, but also stable isotopes. And stable isotopes allows us to look at mobility and diet, and of course, ancient DNA allows us to really figure out who the Picts were from a kind of biological sense, right? We can compare the ancient genomes we sequence from a Pictish context with those of Neolithic and other medieval populations in the world. We're all related, right? And so by accessing and sequencing the DNA, we can gain a really good idea of who the Picts were from that point of view. Rick Knecht and the Nunalek project was recently named one of the 100 wonders of the world, and it was also featured in COP26 themed journalism, and specifically a big expose, I guess, in the Washington Post. So our archaeology is very much important for the wider field and the wider community, wider scientific community, I should say. On that note, I will finish there and then hand over to Matteo. Thank you.
Thank you, Linus. And I'm sharing my screen. Just a second. Okay, perfect. So yeah, thank you very much. This is just an example of one of the many research that we conduct within geography in the school. And it's a project that, in fact, was presented less than a week ago at COP26 in Glasgow. And it's very much of a collaboration between the Cryosphere and Climate Change group within geography and the ICE-TUPA team, who live and work in Ladakh, and the JNU University in India. Now, just to put this into context, we all know that glaciers are spectacular expression of how climate change, in its simplest term, as temperature rise, glacier shrink, and here is one example from the US. So with this in mind, we have been looking at this region, the Ladakh region in the Himalaya, and analyzed over 2,000 glaciers over a period of 42 years. And unfortunately, but as expected to some degree, we have discovered that almost all of the glaciers analyzed have been retreating. This is simply measuring the length of a glacier, and as we can see, these glaciers have been retreating at a rate of about 8 meters per year. It might sound very little, but these are very small glaciers, right? They're mountain glaciers, and over the 42 years, on average, they've lost more than 300 meters, which means effectively that for a glacier of a kilometer or less, this is more than a 30% loss. We've also been looking at the snowline altitude, which is a way, kind of a sophisticated, complicated way of measuring the glacier mass balance. And again, what we see, unfortunately, is that the snow line has been rising by about 2.5 meters a year. Doesn't sound much, but it's more than 100 meters over the 42 years. And these are glaciers that maybe span an overall of 200 or 300 meters. So it's actually a dramatic retreat and shrink and volume loss of this glacier. So this is what's happening in this region. And of course, you know, the glaciers are beautiful indicators of climate change. They're spectacular. They're all over the news. People often mention glacier because of their contribution to sea level, and we're worried about what might happen in Greenland and Antarctica, and that's all very good. But in this region and in many other regions in the world, glaciers bring water to people. And this is an extremely arid region. It's almost like the Sahara Desert. It really doesn't rain much at all. And all the water that the local people can use is the one that comes from the glaciers. As the glaciers shrink, the water is no longer available. So in order to find a solution to this water resource issue in the area, the iStupa local teams have come up with an idea, which I will show in a minute through a video. But of course, that's only a temporary idea, temporary solution to the problem. Long term, we need to look at something different. And there will be a second video that mentions what the long-term solution might be. So let me switch to the video. Just a minute. Sorry. Yeah. Glaciers are an exceptionally good indicator of climate change. Simply put, as temperatures rise, glaciers shrink or disappear altogether. Glaciers are essential to the ecosystem of the mountains, and that includes the people who live there, the local rural communities who live there. In order to slow down this crisis and increase resilience, the Cryosphere and Climate Change Research Group of the University of Aberdeen has been working in collaboration with colleagues from Indian universities as well as locals in the Latka region on the iStupa project.
This winter we have roughly storage 2.5 million liters of water, and in summer this water directly goes to the steam water, and which used by 400 families down in the Pyang Valley.
Once those natural glaciers are gone, these kind of interventions or techniques, they are also not going to work anymore. So a bigger picture is that we have to kind of study the effect of climate change on natural glaciers and how we can mitigate them and how we can prolong the life of our natural glaciers.
I am in Tarchit village, one of the most beautiful ever villages in Ladakh, I think. It's high up where I am, roughly 4,000 meters. The people here made this wonderful ice stupa, which was one of the tallest in Ladakh at 120 feet. Now it is mid-June already, actually right middle of June, and it has half melted. Still it is some 80 feet tall. And this village is very, very, very special for a visit, whether you are from Ladakh, the rest of India, or from anywhere in the world. Beautiful mountain valley with some 30 beautiful families with very welcoming people. And the surroundings are all these granite monolithic rocks full of rock formations that have mystical, spiritual connections, as people here believe. Lots of stories all around, caves for meditation, and fields green with peas, barley, vegetables. And then this is one village where it's so high up there that only barley grows. And down in the village, some 500 meters of height difference, the lower part of the village grows wheat and even apricots, which is something that only grows in lower Ladakh. I'm amazed what a variety of things that this village has to offer. About the courage and spirit that groups in different villages have shown to make their own glaciers, however small or big, rather than sitting hand on hand against this challenge of climate change. We'll also be spreading a message from here to the world so that their lifestyle can make it easier for us in the mountains. I'm here with children from all over Ladakh. We are here to give you a message to the world and to start a movement to live simply. Because of the lifestyles, the complicated lifestyles of the people in the world, we in the mountains are affected heavily by climate change. We have flash floods followed by droughts, and the measures we take to conserve water or make artificial glaciers do not take us anywhere unless you in the big cities change your lifestyles. So today we appeal to you to please pledge to change your lifestyles and make it simple so that we in the mountains can simply live. As Gandhi said, live simply so that others may simply live. We want to appeal to you that you have to adopt measures that are not harmful for others. Please live simply.
So we may simply live.
And as we greet and bid farewell in Ladakh, we say, Jule. Jule!
Right. Thank you for listening. And now I'll move to Javier Martin-Torres, who's the head of the Planetary Science team in our school.
Hello, everyone. Well, it's a great pleasure to be here today and to talk to you about the activities of the Department of Planetary Sciences. I'm going to do a quick review of all the activities of the team. And the first thing that I would like to emphasize is that the Planetary Science Group is focused on the study of Earth and planetary atmospheres and the development of instruments for Earth and planetary exploration. So we develop instruments that we later use to analyze and produce science and publish papers. And what I would like to highlight is that the team is a multidisciplinary team. So we have collaboration with geologists, biologists, physicists, engineers, and so on. So we are by nature, we are a very multidisciplinary team. I'm going to emphasize today, I mean, these are the 6 main topics where we work, in mainly Mars, environmental research, geophysics, and remote sensing, hardware development, and astrobiology. I'm going to highlight today the activities on Mars, hardware development, and astrobiology. And because of, I mean, we don't have too much time for review of activities, but I think that this is some activities that will give you a flavor of everything that we do on the team. So we are participating in most of the current past and future missions to Mars. So we are part of all NASA and ESA missions. We are also getting involved in one Japanese mission to Mars in the future. So we participate in Curiosity rover, the ExoMars orbiter, the ExoMars platform, the rover Perseverance, the Mars sample return. And in particular, something very interesting with our team is that we are very much involved with a few different teams within the school in the ExoMars mission. In particular, there is a team led by Professor John Parnell, who will contribute to Raman spectroscopy of the rocks drilled by the rover once that the mission is on Mars. And we have also staff that are contributing to the field training of the instrument and staff to make decisions during the mission. So we are training the scientists of all over the world, all over Europe, on going to field campaigns and training them about the right decisions to take once we are on Mars. And in particular, we are at the university very proud to have an instrument that will be in the platform that is called Habit, and that will investigate the habitability of the landing site and also will produce liquid water on Mars. Actually, this will be the first instrument that will land on Mars, and that will be led by a Scottish university. This is how the instrument looks like. This is a Habit instrument. As we were testing it on Earth, this is how it looks on a Martian Chamber that we have at the university. This is how it looks now that it's integrated in the ExoMars platform. Right now, the platform is in Torino and will be launched next year from Kazakhstan. Will be launched to Mars in September next year. And it will arrive to Mars in June 2023. So, and after that, we will start analyzing the data. We are very much into astrobiology topics, and we have participated in most of the discoveries with a lot of astrobiological interest on Mars research, especially using data from the Curiosity rover on Mars. So we participated in the first detection of liquid water on Mars, methane, nitrogen fixed to the soil, organics, manganese oxides, and redox. So we are participating. We are participating in the more up-to-date research on Mars research. Using rovers or satellites or in situ instrumentation. And we've been participating in all this cover of the most important magazines on the field. We are also very much worried about planetary protection, and one of the members of the team is a member of the COSPER Planetary Protection Panel in the advisory team. We are also members of the Mars sample return mission to Mars. So we are very much involved in Mars and astrobiology in the team. But to do all this, what we do is we also develop hardware. So we go from idea to development, to field campaigns, in implementation in space missions, data analysis, and publication. So we go through the whole chain from initial idea to instruments that go to another planet, and we analyze the data then. These are a few examples of hardware that we are developing at the university, or we have developed. I wanted to show you a few pictures. This is a Martian Chamber at the university where we simulate the environment of Mars inside, and where we can test the instruments that are going to go to Mars. This is a project where we were able to fly an instrument into a rocket. So these are activities that we developed with the students, a zero-G gravity experiment. We have also been training astronauts in the Bulby mine. Actually, we will go in November, December to the Bulby mine to collaborate also with the European Space Agency, training the astronauts to explore caves. And we have developed this sensor called Pac-Man, and we're going to become the providers for all the major telescopes in the world. This is an instrument that measures it takes environmental measurements, provides also measurement for magnetic field, particles from the sun, and so on. So we are becoming providers for most of the telescopes in the world, the big telescopes in the world. And we are also very much dedicated to outreach. Actually, we are developing this plan this project called Space Northeast, dedicated to students around the Aberdeen area. This is for children between 11 and 12 years old, and we have now the participation of 12 schools around the area, and they are learning a lot about the habit, about the Mars exploration, about the space, and so on. We've been giving talks everywhere and all around the world. So we try to get very much involved in outreach activities. So this is something that all the members of the team are participating on. And within these campaigns of outreach, we've been flying balloons with high schools, for example, so the instrument can put their instruments in the balloon and take pictures, and then have a look at the data that they have been able to take. So outreach is an important part of our activity. These are a few flights from balloons, different places in the world. This is from the minor campaign that we had in the Bulby mine in England. This is the place where we go in November, December to work with the astronauts from the European Space Agency. And this is this rover that you can see here has been developed by us. It's in the university. It's called Core, and it's being used for many groups around the world to see how operation can be done inside caves and in another planet or on the moon. So, of course, all the intention of making all this work to be part of peer-reviewed journals, and so we've been highlighted in many of these journals. We have more than 25 countries collaborating with us. And very recently, in September this year, we have started a Master in Planetary Sciences. We're very happy to have this already running. And hopefully soon we have many students coming from all the UK and abroad. And in this project, I mean, in this way of working, we try to involve the students, not only the master, but also during every activity that we do, to involve the student in the activities that we develop as a research team. So that from scientific, as I mentioned before, from scientific idea to prototype testing and data analysis, we've been incorporating students in all activities. So for us, it's very important that the students get part of everything that we do. And I just wanted to finalize with a couple of mentions that we have from the BBC. One was because we developed a ventilator in the fight against the COVID-19 last year. And we also were mentioned when we discovered the presence of liquid water on the surface of Mars. Actually, Google developed this doodle with the discovery. And that's all that I wanted to mention. Thank you very much. I can take your question. And next, I would like to introduce Jessie Pugsley. I mean, she's a postdoc researcher, assistant in geology and geophysics, and she's researching virtual field trip development, and she did a PhD, the bachelor and the PhD in Aberdeen, so she's very knowledgeable of the university. So please, Jess.
Thank you very much, Javier, and thank you very much for inviting me to do this talk today. I'm just going to showcase, hopefully, some of the work we're doing in the geology department and some of the teaching we're doing as well. So what I'm using today is I'm going to illustrate virtual fieldwork. I'm going to hide this. Right, so virtual fieldwork and what we've been looking at, and we're using virtual outcrops. Virtual outcrops are a 3D realistic model, which is both spatially constrained and georeferenced. And we have a lot of kind of uses and applications for virtual outcrop, which includes, of course, research. teaching and science communication. So we've got a big group of PhD students and undergraduates using virtual outcrop. We're using it in our teaching from first year all the way through to MSc. And we're also looking at kind of outreach with such as the Portsoy Museum, Bothy, Salmon Bothy, and some other different examples where we're using virtual outcrops in those settings. Okay. So virtual outcrops have come on a long way in the last kind of 20, 30 years. So back in about 2003, they heavily relied on LiDAR, which was very bulky, heavy equipment, and of course, very expensive. And around 2011, there was the kind of invent of UAVs and drones. Of course, they were very, very expensive in those early days. And around 2015, the advent of the kind of more freely available drones as we know them now, kind of reduced their price and really kind of helped virtual geoscience really take a big step forward in terms of virtual outcrop. So now with the advent of these kind of more affordable UAVs, drones, we kind of fly around various outcrops in a global setting. So we can go to the Isle of Skye, is what this example is below, Utah, Pyrenees, it's all over the world, lots of different examples. So you fly your drone, we process that back at the university, and we can create these models below, for example. Okay, so of course this was incredibly useful when COVID hit, of course. So we had field trips, and geology really does heavily rely on field trips. It's fantastic experiences to go into the field. However, this guy came along and kind of messed things up a little bit. And of course, we were very lucky and very well positioned to have a wealth of virtual outcrop to kind of use across the globe in various different settings. So we're able to actually make direct replacements of our traditional field trips, say to Utah, for example, which is this example here, and how it looks in a virtual experience here. So we also are using this as both the direct replacements, and we're also using it as a tool for teaching in this current setting. We're also using it just because it's fantastic to use. It's not just a replacement for fieldwork, it can be potentially used as a key tool looking forward into our future of geological fieldwork. And really we are using it at a first year level as well. So I'm going to give you a little bit of an illustration of that. So this is a Utah outcrop. It does a funny thing here. So it's a Utah outcrop. It's right beside Arches National Park. Well, it's within Arches National Park. It's right beside the Visitor Center, which is just this other side of the road. And we're looking at a series of really quite fantastic outcrop and kind of this road cut here. I've placed a car for scale here, just to give you a visual representation. And I've also linked some external Google Earth street views that the students can look and help aid their understanding. We've been able to integrate videos of our own 360s, of our own photos, everything, anything you can imagine, internal and external, we've been able to integrate into our fieldwork. And you can kind of understand what's going on, and students can look at this, they can interpret it, we can show them, say in this example, we've got a series of faults, these fractures that cut through the outcrop here all along. And not only can we illustrate this just with interpretation lines, but we can also kind of add in 3D surfaces to really kind of hammer home the 3D kind of function of geology and the 3D application of geology, and how these linear features and these faults are actually 3D surfaces that propagate through the cliff. So we can ensure that the students are understanding and seeing what we see in the field. So we can also integrate kind of other representations and kind of schematic diagrams so that the students again can help understand what they're looking at. So Aberdeen has been heavily involved in kind of launching this oh, sorry, my links are missing. This program called, well, this web page called V3Geo. It has at the moment about 400 and I think it's 247 virtual outcrops on it, and you can actually browse them, have a look at them. They're globally distributed. I have an example here of one we collected, head of school David Muirhead and myself, we collected on the Isle of Arran last month. And you can actually launch it and navigate through it yourself here. So anyone can have a look through this model. If you click on this link, you can actually launch it and navigate around it. I have it in this program here, just in here. And you can actually have a look at it yourself and navigate around it, no problem. But we're using it as a as a tool for our teaching in Aberdeen, in addition to our research as well. So that's kind of a showcase of how we're using virtual outcrop, and hopefully that's clear. I'm happy to answer any questions.
Thank you, Jess, for that, and thank you everybody else for your presentation there. So back to me, head of school. I hope that's given you a bit of a flavour in terms of what we've been up to recently in the school. And I'm leaving this slide up here as just again to reinforce the kinds of interdisciplinary research and teaching that we're doing, a list of our MSc programs that we run, and hopefully just showing that what we try to do a lot in this school is to just keep asking questions, inquiring, asking questions, and trying to pose the big things. Examples there about how we can use the geology of the moon to understand Earth's evolution. It seems like the wrong way around, but it's actually very useful. How do we use ancient weather studies to predict current climate change? Again, we're trying to build all these things together into a big interdisciplinary sphere. The key thing here is that we love being curious about the Earth and the natural world around us. And again, what this can tell us about our rich history and even aid in planetary exploration. At our heart in the school, our main key is to try and understand our past, in essence, to try and sustain our future and have real understanding of where we're heading. I'd like to thank you again for listening and taking part this evening. Thank you again to all our presenters for sharing the kind of teaching and research we've been up to. And I think for the next little while, we'll hand over and be delighted to answer any questions from yourselves. I wonder if Nicole or Gary, are you going to lead that, or would you like me to start off with the chat on the side?
Yeah, I'll kick off. Thanks, Dave. And we'll get some of the questions that have been asked in the chat. And if anybody has any questions that they'd still like to ask, then please feel free to pop them into the chat and we'll put them to Dave and the panel to get some answers. But firstly, thanks to you all for your presentations. Great to see what the school are up to and what the how the school adapted in recent circumstances. And as one of my colleagues has just texted and said, geoscientists have amazing jobs. So it's great to see. First question is from Ian Patterson. This is a question about the origin of the Picts and DNA. My family originates in the Afford area. Recently I received results from my Y-DNA and was somewhat surprised to find out that most people with similar DNA are located in southwest Ireland. Is that unusual? My family on both sides are firmly rooted to the northeast, and I've always thought I must have been a Pict at one time.
Thanks, Gary, for that, and thanks, Ian, for that cracking question. I'm going to plead ignorance here and hand over to Linus, our bioarchaeological colleague, to hopefully be able to handle an answer for that one. Thanks, Linus.
Thank you, and thank you, Ian, for the question. I have actually uploaded a slide that I can use here. Let's see if I can share this now. So this is essentially a principal component analysis of genome-wide data we have from 4 Picts. You can see them down in your left corner. They're highlighted. And what we can observe here is that, so this is taking a broad look at the genetic variation we observe in Picts. We can observe that, let's see, I'll try to keep this short. You should all be able to see this. Here we have, so this is Stone Age genetic variation in Europe. So we have British Mesolithic individuals, we have other European genetic variation. Then we have the kind of last Stone Age when agriculture was introduced, right? And we find a cluster here of British Neolithic individuals. And they look quite similar to Anatolian Neolithic individuals. In fact, they're a bit of a mix between resident local hunter-gatherers and migrant farmers that brought farming and a sedentary lifestyle to Europe once upon a time. During the Bronze Age, so this is just a few thousand years ago, there was a second major genetic ancestry represented here by the Yamna pastoralists from the Pontic steppe that was introduced to Europe, right? So it was massive large-scale migration. And that resulted in a kind of mix of all these genetic variations. So people admixed essentially to create what is now the Central or West and West European ancestry. And we observe that the Picts fall in that area, right? So that's a kind of broad scale answer to who the Picts are genetically. It's a mix of local resident hunter-gatherers that once upon a time lived in Europe, who were later mixed with migrant Neolithic farmers that brought a new lifestyle and production, domestic animals and plants and so on. And then the third Bronze Age type genetic ancestry. So the interesting part is that we now know that the majority of R1b and R1a Y chromosome genetic variants were in fact introduced to Europe with this last major migratory expansion into Europe during the Bronze Age. So I can tell you that your paternal ancestry is very likely to derive from that massive kind of migration into Europe during this time that later homogenized the European gene pool. The Picts themselves did carry R1b. We don't have that much Y chromosomal data, but we also know that there were links, cultural and genetic. So people moved back and forth between Ireland and Scotland during the early medieval period. So it's not unlikely that you can actually trace some of your genetic ancestry as a Scottish person to Ireland at some point back in time. So that's not a very specific answer to your question, but I hope that helped clarify the picture and the history of that to some extent. So the short answer then is yes, you could very much have genetic affinity to modern day Irish populations and still have Pictish genetic ancestry.
Great, thanks, Linus. A question from Stuart this time. How will the advent of a Scottish spaceport influence the planetary research at Aberdeen?
Thanks, Stuart, for that. I'm going to hand over to Javier for that one. Javier, can you take this question?
Sure. Well, I think that will be very important. Actually, I hope that it will be very important for the development of space and planetary research in Aberdeen. But first of all, I think that it will attract people, not only from Scotland, but from all over the UK and Europe and abroad, to come to Scotland and to participate in the activities in this Scottish spaceport. And also from the point of view of the Department of Planetary Sciences, where we develop instrumentation for space, it's very important to have a place where we can increase the technical level of the instruments that we developed. So one way to do that is to fly experiments in a rocket, like we could do in this spaceport, and prove that our instruments, they can survive like launches, they can survive to space radiation. So it's a very important infrastructure that we will have close by, and I'm sure that it will be very helpful for planetary research in Aberdeen. Probably take the next question too, isn't it?
Yeah, well, the next one is for you as well, I think, Javier. So is there a conflict of interest in the school between the live simply to simply live message and the work to support scientific research on Mars?
Do you want to start first, Dave, or should I?
Yeah, sure. I'll kick off, Javier. Absolutely. I think it's a really good question. I think it's one of these questions that often comes across a lot in science when we're looking at, how do you justify things like NASA and ESA, and we still have got to deal with poverty and the UN SDGs. I think it's one of these ones where at all times you've got to think about how we do things, the ways in which we do it, trying to make sure these things are performed sustainably. I think one of the things that Javier will come on to is a lot of the research that we do, we're aiming to try and better the world around us. So we do that sustainably. We're using research money that is only going to be spent on that anyway, and trying to build on that, bolster that, and find solutions. So a lot of the work that Matteo and others have been doing with the ice stupas, that Javier and his team perform, a lot of that is to use remote sensing activity. So using space technology to understand the Earth, that helps us understand what we're doing in local communities as well. So I can understand often that tension between the two, but I think there's a space for this to work together. And maybe Javier can answer a little bit further about that.
Yeah, well, I have several points here. I'm used to this question, actually. I think that, the benefits of planetary exploration and space in general for society are enormous. It could be 2 hours in a row talking about this. I mean, it's been improving the health care on Earth. It's been improving our daily life. Everything that many of the devices that we have around have been developed thanks to space exploration and planetary research too. I mean, we are also protecting our planet and our environment using the satellites that are used to monitor this our planet. I mean, they have been able to enhance our safety on Earth. I mean, we have been able to prevent the impact of earthquakes, for example, of hurricanes, thanks to space development. But I would like to go closer to that, actually. I mean, because this is something that it really touched us in Aberdeen. We have developed an instrument that we go to Mars and we produce liquid water there. And the same principles that are used in this instrument will be used to produce liquid water in desertic areas. Actually, a couple of years ago, the team won a prize, an award in UAE in a contest about the devices that can be taken from space to Earth to society, and our device won the second prize in the contest. And so we got some funding to develop some prototypes in the desertic regions in UAE and in some parts in the south of Spain and North Africa. So the activities that we develop in space or Mars are useful for Earth. And not only that, at some point, Mars in the past was like Earth. It was full of water. And now it has no water. So why that planet that was so similar to Earth lost all the water? So it's probably something that we want to learn. We don't want that happen to our planet. So it's good to study Mars to see what is the future or the fate of the Earth. So I could be talking about this, about how many things are beneficial from space and planetary research or Mars research society. But I think that this is just a few samples. Thank you for the question.
Thanks, Javier. I want to go back to a question that Katrina asked earlier, and Linus has answered it in the chat, but just in case folk haven't seen it in the chat, Katrina's asking, how are the coastal archaeological sites that are being eroded rescued?
Yes, thank you for the question. I'll actually read my answer. I think I managed to formulate it quite well. So it is a good question. And with rescue, we mean an excavation or a rescue excavation is something that requires urgent excavation because otherwise it will be lost. So essentially, we rescue the material culture such that it's preserved for future generations. And the approach we took for this specific project as a department was to embed the research, embed the archaeological excavations and the preservation of these objects in the local communities. So thereby, knowledge exchange and providing tools for local communities to preserve and manage their cultural heritage. And so it's rescue excavation in the sense that a lot of the material that is now displayed and covered in media and especially in relation to COP26 and so on, it would have been lost otherwise due to erosion. So it would have been eroded into the sea. And I think there was a second question for me, right?
Yeah, there's one from Tora here. She's asking about archaeological research into Vikings. Are there any particular excavations or other research projects going on at the moment? Is it mostly focused on evidence of Vikings travelling to the British Isles and Americas, or are the university involved in research in Scandinavia as well?
Yeah, so on a personal level, I'm involved with research in Newfoundland and Lonzo Meadows. There's really famous archaeological Norse site. And so hopefully I'll be going out next year, next field season, if we can travel again to Canada. But we also currently hold material from Lonzo Meadows for the purpose of extracting and sequencing DNA from a very finely dated sequence in a peat bog just adjacent to the Viking houses that were excavated a number of years ago. And we've identified new cultural layers, so dating to the period of the Norse occupation. So we'll be looking for presence, absence of domestic animals. So at present, there's been no evidence that the Norse brought with them domestic animals, but there is reason to believe that they did, which we know they did when settling Greenland, for example. It's just that the occupation was so short, so brief, that archaeological remains, physical remains, may not be preserved very well. And that's where DNA can be particularly useful. So we'll look for DNA molecules from that were left by domestic animals, potentially in this peat bog. Apart from that, I'm personally also involved in a bit of research, but kind of peripheral in larger research projects in Sweden. We collaborate with Stockholm University, Uppsala University in Sweden on various DNA projects. That's just me. Vikings or Viking period forms part of that. However, Charlotta Hillerdal, who's our Viking specialist, really is very much involved with research in Viking context in Scandinavia. So there are big networks and affiliations, essentially. Yes, I hope that helped answer your question.
Great, thank you very much. And I think probably the final couple of questions that we'll have this afternoon, just before we wrap up, a couple of questions about the virtual field trip work. Firstly, from Nicole, how has the virtual field trip work compared to the in-person ones pre-COVID? And from Thomas, are there plans to fully replace field trip work in the future for students with the virtual field trip work previously mentioned?
All yours, Jess, go for it.
Thank you, Dave. Yeah, excellent questions. And this is actually what my postdoc is on and exactly what I'm researching. So in terms of how they are run, I actually have one I can give you a really quick example of that we're running at this moment in time, currently downstairs. I've actually just popped away from it. But essentially, it's when they're like-for-like replacements, it is almost exactly the same as a normal field trip in terms of when we can, and the locations we've gone to, we have virtual outcrops of, we'll run it in the same kind of order. However, if it's logistically better, kind of you don't have to drive miles, and you know, sometimes virtual, but sometimes real field trips are dictated by geography and actual locations being distances and so on from each other. So there's a logistical kind of element of that we can bypass in virtual field trips that actually can be really beneficial. So this is actually one that some of our master's students are looking at. But essentially, it's the same. This is a location here that they go to, and I can actually shove a car in here so you can see. It's quite a large outcrop. This car has kind of been sunken into the ground a little bit, but that's it there. Actually, there's a real car here. But the students are actually able to navigate exactly the same in the field. You know, they go off and they explore, and in some instances we'll have extra material like photos that they can have a look at and so on. And it's essentially the same tasks that they can operate in. Following on to the question, and in terms of that, we don't just replace fieldwork, like I was saying earlier, we also are implementing it into our undergraduate in times where we might not have had fieldwork in that course. So it's actually kind of enabling us to take a concept that we may have used photos for or maps for, and we can actually integrate maps, photos, virtual outcrop, all into this immersive experience that we can really kind of hammer home geological concepts in a real world environment. In terms of using virtual outcrops, which are a really powerful tool that the students seem to be really enjoying. I can briefly show you as well, like how it's been kind of rated in terms of year to year. Some of the students. So this is from our master's course. This is kind of surveys that we've been taking, and you can see that this is these are both the fully in-person years. So these are traditional fieldwork years, and the dark blue. This kind of lighter dashed line is a kind of half and half year. COVID hit halfway through the year, and then the top one is entirely virtual. And you can actually see consistently that the students did rate that relatively better, which is actually very, very interesting and surprising from my point of view. I will also add at this though that the students do, in all of the surveys and all of the talking to the students, getting feedback, they do miss fieldwork. They miss the experience of being outside if it is a direct replacement, for instance. And then to lead on from that question in terms of looking at whether or not these will replace. I mean, Dave, I'm sure you can add to this, but I don't think in many ways that they will replace. I think that they will supplement. I think it could be an incredible tool if we could go into the field and ensure, you know, in a real world example, we could have, you know, glasses essentially would be the absolute kind of pinnacle of what we could do, and they could actually allow students to exactly see in the field what we see and kind of help interpretation lines, all sorts of additional information, and they are actually standing in the field and they are using virtual outcrop or immersive reality and so on to really enable them to understand and interpret geology to their full potential. We're not quite there yet, and it's something that we're hopefully going to be integrating, such as on the Iron field trip, hopefully for second years next year. Yeah, we're hopefully going to be applying virtual outcrops to real world field trips there. Okay, thank you.
Thanks, Jess. Nigel's just put in a final question, I think. Has the department considered the future use of drones to go out and return with surveys of remote areas and outcroppings or naked rock surfaces, as with the underwater drones in oceanographic research?
Yeah, thanks for that, Gary. Thanks, Nigel, for that question. Yeah, so a lot of our researchers involved with drone or UAV work are doing this already, trying to build larger scale surveys. I don't know what kind of surveys you're meaning. If in terms of the work that we do in terms of gathering information, some of the archaeologists are doing this to look at site surveys from the air. We've got geologists doing it in various forms. So there are lots of ways in which we are using drones in a lot of what we do to look at remote areas. It's a really good way of getting access to areas that we can't see. So some of the images that Jess showed earlier, prime examples of being able to get a drone up close and personal with rocks that we can't really get to without doing something silly like hanging ourselves off a cliff with a belay device. It's not the greatest idea at times, but yeah, we are trying to look at more remote areas. In terms of oceanographic research, we don't do a lot of that, but it's a good point about that comparison. It's something we'd like to look into a lot more of. As I say, we've got colleagues who are really kind of leading the way on this, and the group that Jess is working in are part of that. So it's great to see that growth.
Thanks very much, Steve. I think that's all our questions. Thank you very much to everybody for your questions, and I'll hand back to Katrina just to wrap up the event for us. Thanks, Katrina.
Thank you, Gary. And a huge thank you to Dave and to Linus, Matteo, Javier and Jess for their fascinating updates. It was just incredible. And of course, a huge thank you to our alumni attendees for joining us and for the great questions today. If any burning questions have occurred to you after the chance to ask them, please just drop us a note by email. We're at alumni@abdn.ac.uk and we'll be delighted to help. So take care, everyone, and thanks again for joining us.